So, welcome everyone to my talk on our long-term mixed method study on nutrition assistance systems. First of all, I'm very grateful for this award, and it made it possible for me to come here in person this year. And this is a joint work with my colleagues from the Technical University of Munich, who could not be here today, but I will present it. So what is this system all about? You might know these kinds of decisions. Probably you already had like a few dozen of those today. Every day we ask ourselves, what should we eat, when should we eat, with whom should we eat, how much should we eat, and in which order. And all of those decisions become really difficult if we are starting to want to optimize for something, like, for example, healthy nutrition. And in this research, we asked ourselves, how can we build a personalized socio-technical system that would help people improve their motivation to eat healthy, their knowledge about nutrition, and in the end, also change their behavior in a significant regard. And at the same time, we knew this is tricky because, of course, this has been studied for years already, and if we look around ourselves in the world, there's no solution yet. So we also wanted to study what are the limitations of supporting healthy nutrition with, for example, a recommender system. Now, you probably know some of those apps. Of course, there are commercial apps available for healthy nutrition, like MyFitnessPal, FatSecret, Lose It, Noom. But most of those applications actually focus on weight loss. So a crucial part in them is that you count your calories, you cut your portion sizes, and they track how much you weigh over time. What we wanted to do is a little bit different. We really wanted to focus on healthy nutrition, so on how much of each micronutrient did you intake, and was that too little or too much? So it was really an optimization problem over, let's say, 26 different nutrients. And modeling food is not simple. If you look at this picture, well, probably all of you know what is on this picture, but how would you computationally define what is on this picture? Is this an apple? Is it a fruit? Is it a certain amount of calories? Is it maybe a recipe where you have to slice the apple into pieces before consuming them? So these little differences in modeling can make a huge difference in how your application is perceived and how the users can operationalize the kind of advice that you're giving. And the same is, of course, true for the user itself. We could say every person just gets nutrition recommendations based on some model, but we could also go into more depth and say we distinguish between different genders, we distinguish between different age groups. And if you really want to go into personalized nutrition in a biological sense, you should probably measure genetics and microbiomes and then personalize based on those. So in this work, we really wanted to go down the personalization way, not all the way down because we didn't have the budget to do genetic analysis on our participants, but we chose a pretty accurate food database. So we really looked at 26, 27 different nutrients for every single meal and every person. We also chose to include things like blood measures to determine the risk group of a person and to weigh certain nutrients more than others based on those blood measurements. And finally, we wanted to empower the user. So not only tell them what they should eat, but also give them visual feedback to learn about their nutrition so that they could, in the end, in theory, even without the app, realize what was wrong about their nutrition and compensate for that. So this is a schema of our nutrition model. This is the dietary reference intake chart. So for each micronutrient, you have this kind of setup given out by certain organizations like the DACH organization, who list for different genders and different age group how much of this nutrient you should intake. And for some nutrients, there's a toxic area where you over intake, and for some nutrients, you get malnutrition if you have too little of it. But also some of them don't have both sides of the red area. And this is the application we integrated this in. So basically, we have built a whole ecosystem around our recommender systems where we allow the user to track their food intake with this database, to see their progress in different nutrient categories over time, to also see which kind of nutrients they have been lacking recently, and finally to give recommendations for recipes that would compensate for their nutritional needs based on the past 3 days. So these are our recommenders in a bit more detail. We have them sorted by different meals. So we have breakfast, lunch, dinner, snacks. And for each of the recipes, you can get a personalized explanation why this recipe is recommended to you and which nutrient was most responsible for recommending you to eat this. You can also see these little charts that tell you something about how much the nutrients in this meal would change your current nutrient status compared to previously. Now, these are the recommendations, but as I said, we also wanted to empower the user to understand how these recommendations came about. So what we did is we gave them visual feedback on their current status, which is the left top screen, so the 6 most critical nutrients, but also their past status, which you can see in those charts over time, and their future status, which are the little red and green bubbles that tell you if you eat now a chocolate bar or some apple juice, that is what would happen to your nutrients. Which brings us to our study design. We wanted to do a mixed method study. So on the one hand, we wanted to compare groups quantitatively between a control group and the intervention group that got the application, but we also wanted to get some qualitative insights, so we conducted interviews with the participants. As you can see, we first did the comparison between control group and intervention group, and afterwards allowed the people in the control group to also use the application in a secondary study. And then we added some participants to that. So you might have noticed that if you read this chart, there are not too many participants, and this is because in long-term studies, it's really hard to recruit people, but luckily, we also did a short-term study beforehand. So what we did is we had a 12-day short-term study with 100 participants, and we compared the statistical model that we built from this with the first 12 days of our long-term study to validate whether the long-term study was comparable in terms of the effects in the application to a higher sample size. And as you can see, most of the effects are similar between the two groups, but there is one important difference, and this difference, of course, made us very happy. The time that people spent in the application in the long-term study became significant. So our outcome is how optimal they intake the nutrients. And in the short term, 12 days, this was not relevant how long they had used the application. But once we went to the 2 or 3 months, we see that the nutrient intake became more optimal over time. And also the effect of the recommendation interactions was not important in the short term, but in the long term had an impact on nutrient intake. However, there are some challenges, and this is what we also wanted to study in this experiment. As you can see, these are the interactions with the application of all the participants over time, and there is a huge drop in interactions over time. And especially, you might not be able to see that, but the light orange one are the recommendations. They basically vanish around week 3. So people stop using the recommendations and start looking at the retrospective statistics a lot more, because of course those get more valuable if you have more data to show in them. So we asked in the interviews about this, and we will tell you a bit more about why people stopped using the recommendations later on. Another thing that we saw in this study, now that we analyzed more clearly what people were using to which degree in the application, is that once we include the visual feedback on the different levels of current status, future status, and past status, those become a lot more relevant to the change in nutrition than the recommendation itself. Actually, if we include those kinds of interactions, the recommendation is not a significant factor in the optimal intake anymore, which was a bit sad for us, but is also understandable because, as you will see in the interview, people were just not able to process that kind of fine-grained personalized model. Next, we looked at the interactions with those visualizations. So as I said, we had these 3 levels of feedback, and we looked at how much different users were using the visual feedback. And what was interesting to us is we didn't personalize for that, but of course also these interactions are very personal. So we have some users that only look at the future values and the visualization of what might happen in the future. We have other users that only look at the retrospective data, and we have also users that are only concerned about their current status and base their decisions on that. So this is one of our future recommendations. We should also target the different goals that people have and the different ways that they learn from a system in the way we personalize the interfaces. Finally, we also tracked calories as a kind of gold standard questionnaire, both in the application during usage, but also before and after the study, so we had some ground truth to compare to. And this is another important aspect of these kind of food recommender systems, because as you can see, all of the blue bars, even with all the variation between the users, are below the gold standard questionnaire. And of course, this is understandable because in the usage of a daily application, people might leave out their chocolate bar that they had in the afternoon, or they might leave out a complete day, or they might underestimate the sizes of the food they are intaking. And this needs to be taken into account in the recommender system because, as I said before, we are basing our recommendations on the past intake, and if that past intake is incorrect, we might recommend the wrong nutrient optimization. Finally, we did some qualitative studies with questionnaires and interviews on those participants in the study. And we asked them, what did they actually change about their nutrition? And as you remember, we had a very detailed model with blood values and micronutrients. But when we asked people what they changed, they told us things like, we started eating an apple a day, or we started halving our portion sizes, or we added some more fiber into our meals, went for the whole wheat instead of the white bread. So we saw that really the level of detail that we were providing with our system was interesting to users. They had positive feedback on that, but it was not operationalizable. So they were not able to actually take this into their everyday life and use it as a recommendation. We also asked what were the challenges in following the recommendations, and here we see some classical examples like the social context is very important, whether you eat in the canteen with your colleagues or you go to a birthday party. Those are the things that led to dropout because people were not willing or able to follow the recommendations anymore. And of course, those are also things that the system could integrate and kind of make a compromise with the user about those kind of social events if we knew them beforehand. So here are a few citations from the interviews, and we especially wanted to know from people about why they stopped using the recommendations after those 3 weeks. What was it that challenged them in following the recommendations so much? And what we saw as a pattern was that they often mistrusted the recommendations. And we built this application with nutrition scientists, so we're pretty sure that the recommendations are based on accurate health advice. But it didn't match the mental model of people because they were not accustomed to thinking on those micronutrient levels. Even though we gave them explanations of why we recommended recipes and they valued those a lot, they still did not believe sometimes the things they should have eaten. And the second major point was the diversity of the recommendations. People complained that the recommendations became repetitive quite quickly. And that is something that we had a closer look into as well. And you can see here, and that was interesting to us, we actually checked the diversity, that is the top row of the charts, and the diversity is not that bad. So within a list, the top 10 recommendations are a very diverse set of recipes that people can choose from, and they really have some way to explore and to also go in different directions with their meal. But what was not that good was the diversity over a sequence of days. And this is especially true over the days where people missed entering their lunches or missed entering their meals at all. So if we clean the data set for those people who entered data before receiving the recommendation, the diversity becomes a lot better. But of course, it's effortful to track really every day, so we need to think about ways to automate how we can estimate things that are missing in our data and still provide a diverse sequence of recommendations. This concludes this talk. Of course, in 12 minutes, we can't really tell you everything about the 50-page paper, but if you're interested, please read up on the rest or come to me later on. The future directions that we think we really need to investigate is, on the one hand, better tracking tools. So there are new methods out there like glucose sensors that are now being adapted to also measure lactose levels and other kind of metabolic signals that would allow us to give personalized food recommendations. We also need better nutritional models that kind of can translate the complexity that is underlying the food decision into something that is more operationalable. And we need to tailor the interfaces that we're using to the personalities that are using those interfaces. So really provide them the visualization and the feedback that they as a person need to change their behavior. And as we saw, social context is really important in these kind of recommendations, and if we don't incorporate them into the application, they will lead to dropout of the participants over a long time. And once we solved all of this, of course, we can also transfer it to other health domains like physical activity or sleep. So with that, I want to thank you for your attention, and I'm happy to answer any questions you might have.
Yeah, so there are some questions on the chat, so it's people are very interested in this topic. One question I would like to ask here also, because it's interesting, so what's happening to the app? Is it going to be made available also in the future to a broader audience?
So the project continued in Munich, but I left Munich, which means I'm not working on this app anymore. I'm working on new apps now. But it is not planned that it will be commercially released because we involved nutrition medicine people, and they would require a lot of ethical approval to provide this health advice as an application. So it would have to go through a TÜV certification for medical applications, and we were not willing to go down that road.
So, but they are still working in this direction?
They're still working in this direction, yes.
Is there a question here in the audience?
I see someone walk to the microphone.
Ah, yeah.
Hi.
Hi.
So yes, I have a question. My question is, are you mainly focused on trying to reach the intakes of different nutrients, or do you take into account some recommendations that are like, for example, avoiding eating too often red meat, avoiding saturated type of fat, things that are maybe you won't see in the nutrients, but yeah, that are not very healthy. Because I think also about that when I saw they were talking about the I don't know, a dessert like tart, something, which I don't really see a situation where it's really healthy. Maybe it's good for mental health, but it's, you know.
So some of those 26 nutrients were actually how saturated fat is. Is it poly or monosaturated, or is it saturated? No, poly, mono, unsaturated or saturated fat. So we included those. We actually also included calories into that, depending on your BMI. But that was more a regulation of the portion sizes. So we would still recommend the same recipe, but we would change how much of it you should eat. And there are also some future extensions. The model is pretty easy to extend with new rules. At the moment, I'm working with a student on an app that includes CO2 footprint, for example. So can you eat a similar healthy meal, but with less CO2 footprint? Thank you.
So in general, so there is also the question, what are the features that were most important, or what you think that to generate these recommendations?
You mean the data features or the interaction features?
I think the data features.
The data features. I think it really depended on the person. So for some people, they told us that it was always the same nutrients that made them look bad, and it was hard to change their behavior in the way to get everything into a green balance. But things like calcium or folic acids, I think those were really hard to get. And we also used, not in this study, but in the short-term study, a scale on how difficult each nutrient is to make the easy nutrients less important and the difficult ones more important.
Thank you. So there are a lot more questions in the chat, so maybe you can take a look. And
I'll answer them in the hub.